Hi everyone, and welcome to this Get More Insight Day presentation for the Electrical and Computer Engineering Department. My name is Alex Wyglinski. I'm a professor in the ECE department here at WPI, and over the next several minutes, I'm going to be talking about this department, what does the curriculum look like, what do the faculty do, and how is this all useful, okay, after you graduate from WPI. And that last one's going to be really important. I'm going to start with that first, because we live in this time, right, the information age, that uses a lot of like information technologies, embedded technologies, microprocessors, machine learning, data science, clouds, and all these other innovations that make like the quality of life of everyone kind of a lot better compared to a century ago, right? These modern conveniences that were only science fiction even a few decades ago. So with that, that's going to a great segue into this first great concept diagram of smart world, all right? So in this diagram, we see a lot of things going on: windmills, planes, interesting looking metropolitan center, connected and autonomous cars, some people with some sensors on them. But this is all electrical engineering technology, right? So we have green energy, things like windmills, things like solar cells and solar panels, smart grids, ways of sending that electricity from these renewable and sustainable sources to all of us, right? This is all electrical and computer engineering. Communications, navigation, GPS, 5G technologies, Wi-Fi. This too is electrical and computer engineering technology in action. You'll see a lot of that here at WPI ECE. E-health, like whenever you go to the doctor's office or to the hospital and such, or you see people with prosthetic limbs where you have motors that are controlled by the person's nervous system and such, as well as sensors such that people don't have to stay in the hospital, but they can be at home but monitored by healthcare practitioners. That is electrical and computer engineering technology, again, covered in our department. Connected autonomous vehicles, not brake pads, not steering wheels, not bumpers. This is all ECE, right? To control algorithms, to control the autonomous vehicles. The wireless technologies to connect the vehicles so they can do actions in a more coordinated manner and make the roads safer. The sensors that detect what is happening around each vehicle. All of that is ECE. All of that is covered through some extent through our program here at WPI. Even environmental sensors, like the observing, like let's say specific types of wildlife, or monitoring the health of buildings in terms of like how are they doing, do they need repair? The sensing technology and the sharing of information and the processing of that information is also ECE. And then finally, smart infrastructure, smart homes, smart communities, smart spaces, smart cities. The ability for the city to tailor itself, become more efficient, and engage with the human population. That is smart world, that is ECE. So, what is electrical and computer engineering? You might think it's green computer boards with blinky lights on it, but no. ECE is about teamwork. ECE is about critical thinking skills. ECE is about taking on really challenging problems and coming up with practical, efficient solutions, right? And in our department, through our curriculum, which about at least 50% of the courses in our undergrad curriculum is project-based, you'll learn these skills. You'll learn the cutting-edge theory and techniques in our classes. You'll work with others, your classmates, on really cool projects that define the current state of the art. And so you'll master these techniques in preparation for your careers after graduation, right? And it's across a variety of topics like the ones I just talked about on the previous slide, like e-health, like connected autonomous vehicles, and green energy and sustainable and renewable energy. So you might say, okay, great. So ECE is about smart world's about these topics. ECE is about teamwork and project-based experience and collaboration and critical thinking skills and problem solving. Okay, awesome. Now, what was the faculty? What did they do? I've got to do an MQP with someone at some point if I choose to do an ECE major. What do they do? And could they be great MQP advisors? And what topics are covered? Great question. We got a ton of faculty in the department covering a breadth of topics like the ones I just discussed on the very first slide with respect to the vision of Smart World. So first of all, that e-health topic I was talking about, we've got 7 faculty that specialize specifically in e-health. Professors McNeil, Polavon, Ludwig, Guler, Makarov, Huang, and Clancy. So all of them cover different topics, everything from biosensors to prosthetic limbs to body area networks. These professors cover it all. Then there's this thing called cyber-physical systems. This is the interface between the information world and the physical world, and includes these 7 professors, including me, Professor Wyglinski, but also Professors Brown, Huang, Bada, Nababi, Amisha, and Zhang. And they cover topics like machine learning, systems engineering, FPGAs, and signal processing. Then, oh boy, cybersecurity. Because in our information age and the smart world, there's always these malcontents. There's always these bad people that are trying to take something that is supposed to help humanity and turn it into a negative, like stealing credit card information or stealing your identity or corrupting your hard disk and such. And we have an excellent team here at WPI ECE specializing in cybersecurity, like Professors Sunar, Shoma, Clark, Ganji, Tajik, Moose, and Daraz. And then finally, power and sustainability, we've got 2 awesome professors specializing in that, like Professors Batar and Mughal. So here at WPI ECE, we have an excellent a collection, team of professors that are here to mentor you, teach you the latest in smart world across these different topics. Now you look at the sort of program sheet, if you will, of what is the ECE curriculum, and it looks, well, you know, like snakes and ladders. It's like box, 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 and a lot of arrows. Let me describe this a little bit more, right? So first of all, when you start ECE in your freshman year, what's going to happen is you're going to be taking ECE 2010. That's our introduction to electrical and computer engineering. Whether you know circuits really well or you haven't really taken any circuits classes before, as well as other sort of like, fundamental concepts in electrical and computer engineering, when you walk away from this course after you graduate with it, you will know this material enough to be dangerous with and to be able to go through the rest of our curriculum. So important foundational course. If you want to know what ECE is all about, well, we also have ECE 1799 in order to say, oh, so that's what ECE is all about. Then you can take ECE 2010. So awesome. And then we have 4 fundamental ECE classes after 2010 that allow you to get kind of a sense of the different sort of disciplines under the ECE banner. Things like, for instance, ECE 2019, which is sensors, circuits, and systems. So, you know, continuing on the theme of resistors, capacitors, and inductors and all that, and how do they form more complex and intricate circuits. Then you have continuous time signal and systems analysis. So if you want to know how information is processed and how systems operate around those signals, well, that course is for you, ECE 2311. And then there's 2 computer engineering classes, 2049 and 2029. One introduces you to embedded computing, such as devices like these, right? Like an Arduino and Raspberry Pi and MSP430, and also introduction to digital circuit design, which is like AND gates, OR gates, and logic that's fundamental to every computing device. Then, your intermediate courses. This is when you begin to tailor yourself. Am I a computer engineer? Do I like signals and systems and information technologies and signal processing and machine learning? Or do I like radio frequency design and electromagnetics and microelectronic circuits or power? That's where you begin to develop your concentration, your interest, your depth in the ECE major. And then finally, what happens is at that point, you begin to try and bring all those concepts together into a project-driven class. Imagine a mini MQP specific to ECE in one term. That is ECE 2799, folks. That's ECE design. Almost all alumni from our from ECE always say this is their best, single most awesome experience that they've had in WPI ECE. Then finally, we've got a ton of advanced and specialized courses, everything from software-defined radios to real-time DSP to cryptography and computer security and semiconductor devices and power electronics. Now, you might look at it another way. Our curriculum can vertically be looked at as analog circuits and power as the leftmost column. If you're interested in signals and information and systems and control and biomedical engineering and wireless communications, that's the middle courses that are highlighted here. And then finally, the computer engineers and the embedded devices and the security folks, that's on the right of our chart, okay? Now, what are some examples of ECE projects? Well, obviously, like, you know, I'm showing like a little device, but let's put into context. There's a variety of projects out there, MQPs, IQPs, ISPs, and projects you do in classes. But like, for instance, let me show you one, okay? So let me turn off screen sharing. And let's go check out one. Like, so for instance, these embedded devices are used almost everywhere in our ECE curriculum. Remember, Smart World. Smart World is sensors. Okay, that's great. But that information from those sensors got to be processed and they got to be conveyed somewhere. So what ends up happening is, first of all, that sensing information usually gets put onto an Arduino, Raspberry Pi, or some other sort of embedded device. So it takes it, it digitizes it, maybe it processes it, and then it wirelessly communicates it over to some sort of server or maybe a data fusion center. And then that gets translated into something that's useful that can be used, like, for instance, let's say location services, embedded tech, like autonomous vehicles, or, for instance, let me rotate this, something like this. Remember what I was mentioning about environmental sensing and monitoring? Suppose that you have wildlife out here and you want to monitor it and such. What you would use is something like this, okay? And you would have sensors, and then you would put in a weatherized, case, and then you would collect information from this environment. So and perhaps then that sensor is connected to things like this. And this is an actual project here. So suppose you have, let's say, a wireless relay network that you take that sensory information and you convey it ultimately to some node that's connected to the cloud. So this is an actual WPI project here, where in this case, we have an actual point-to-point-to-point wireless network. So combining things like this, sensing technology for environmental sensing, as well as, in addition to that, being able to take that information from those sensors and being able to communicate it point-to-point-to-point, is just one of many examples of what we do here in electrical and computer engineering. And you might say, okay, like the wireless relay units I have here, this is actually an MS project, but we have another project that will be using it for an undergraduate MQP. And then embedded systems, I would say almost all my MQPs at some point use something like this, in addition to a variety of other wireless technologies. So in ECE, you will not only learn the theoretical concepts, but you're also going to learn a lot about being able to apply those concepts to real world problems like the wireless relay I'm talking about, using, and also embedded systems and a variety of other projects that we have in the department. So feel free to ask any ECE professor if you want more information, or myself, and you know, and hopefully I'll see you in class one day. So with that, thanks again, and have a great rest of the academic year.